So this is problem 1 on the quiz on matrices. This is the 4x4 matrix that we were supposed to find the determinant of. And so in order to find the determinant of this matrix, you need to multiply each of the terms in any row or column you choose. I chose the one highlighted in blue. Multiply each term by its cofactor, and then add all the products of those terms and its cofactors together in order to find the answer. And so in this case, I chose the row highlighted in blue. I had 3 times its cofactor, then 0 times its cofactor, then 2 times its cofactor, and then so on and so forth. And because anything times 0 equals to 0, there is no point in finding the cofactor of this this part of the calculation and this part of the calculation. So I just cross it out, or I guess I wouldn't say eliminate, but just didn't bother looking at it because I knew the answer would be 0, and just focus on trying to find the values in calculating each of these 2 parts of the problem in the calculation in order to figure out how to find the answer. And so this is 3, and this is the cofactor, which is -1 to 1. Sorry, this doesn't make sense. But initially at the beginning, it's supposed to be, as you can see over here, -1 to the I plus j power. And since 3 is in the first row and first column, it would be 1 plus 1. So -1 to the second power, which would equal to +1 over here. And then for 2, it would also be a positive 1 again, because it would be on the first row but third column, which would be 1 plus 3, and that would equal to -1 to the 4th power, so that would give you a +1. In this case, when I tried to find the cofactor, I didn't really bother trying to find I and j. I just knew this part would be positive or negative by doing plus, minus, plus, minus. I knew each term next to the one that I was looking at would be the opposite sign of the one that I was looking at. So this was positive, and this had to be negative, and if this was negative, then this had to be positive. And you could also do this vertically as well as horizontally. So if this was positive, and this had to be negative. And this just works because when you go up or down, you increase the number of I or j by 1, and that would make the sum of this odd or even, and that would affect whether or not this entire thing would be positive or negative. Anyways, you find out what is, first you have to look into what is the discriminant of this minor now that you have left behind for each of these. And so I again decide to look at the row over here in the middle for the determinant of this matrix, and a row over here at the bottom for this matrix because it had the most zeros. And so if it has the most zeros, it makes it the most simple to solve, because then you don't have to solve for these 2, you only need to solve for the one at the very end. And so for this determinant, right, I ignored these 2, and I just went straight to finding what is the what is 4 times the cofactor of 4. So I have 4 over here, and then I know it's -1 for this part, because if you look over here, it's positive, negative, positive, negative. So this part will ultimately become negative, and this will be the discriminant of 4, because when you look at the minor, sorry, I didn't define what a minor was earlier, but a minor is the determinant of the numbers you get left behind when you cross out all of the other terms that are in the same row and column as the term that you're initially looking at, which is 4. So, you know, all of the terms on 4 on the same column and row, they're out, so what you have left are the -1, 1, 1, 1. You need to find a determinant of that, and times 4 times -1 times 3 times 1, that will equal to the first part of this overall calculation that you eventually be able to find the answer to this problem. So same thing with 2, you know, just finding this to be -1 for the cofactor of 1, because positive, negative, And then when you cross out, all the numbers are in the same row and column as 1. All the terms. Did I say terms? I'm not sure. You just have 0, -1, -2, 4. And now you have these two parts. Finding the determinant of a 2x2 matrix is simpler than finding the determinant of a 4x4 or 3x3 because you actually have a formula that you know how to use, which is multiplying the two numbers over here and then subtracting it from the product of these two numbers, which is what I wrote over here and what I wrote over here. And once you get all the calculations through, you should be able to get 28 as your final overall answer for this 4x4 matrix. And I can confirm that answer to be true by looking at my calculator. I have a Casio, so it's slightly different than how you would, I guess, check on your calculator. My bad. But I can definitely prove to you that the answer is correct, because when I look at the matrix, right, I'll show you the matrix that I inputted, which is over here, right? 4x4 is this, right? You can look, pause if you like. I'm going to exit now. Now I'm going to go to option, and I'm going to find the determinant of the matrix that I inputted the 4x4 in, which was A. And then if you look at it, it'll say the answer is 28, which means that what I put, what math I did here was correct, and I was able to solve it correctly. I didn't do well. I didn't necessarily get this right on the test, though, however, because I didn't do the minor part correctly, as you can see. Though I did everything else correct, and I knew my answer in the calculator did not match, but I checked it over and I couldn't figure out, so I was sort of just left with this mess. But now I understand, and now I learn. Hopefully I won't run into this mess ever again.